In this class, we're going to talk about atomic structure. We're going to learn what an atom is made of, okay? Let's start by defining what is meant by atomic structure. Atomic structure refers to the arrangement of subatomic particles in an atom, you understand? Now, according to John Dalton postulates that atom can neither be created nor destroyed. That means that atom is indestructible, you understand? But through some series of groundbreaking experiments such as JJ Thompson cathode ray tube experiment, Ernest Rutherford gold foil experiment, James Chadwick discovery of neutron, and also Niels Bohr's model of an atom. All these aforementioned experiments show that atom is made up of smaller particles, you understand? So this leads to a significant shift from the notion that atom can neither be created nor destroyed as postulated by John Dalton, you understand? So let's start by let's delve into JJ Thompson cathode ray tube experiment, okay? You see, when we talk about cathode ray tube is like a bottle, you understand? A bottle that is sealed all over, okay? So let me, I'm going to have a diagram here, okay? Please kindly pay attention. This is how a cathode ray tube look like. Okay? So here we have one end and we have a plate here. We have one plate and we have a second plate. This is a typical representation of a cathode ray tube, you understand? In John Dalton in 1897 discovered electron using the cathode ray tube experiment, you understand? You know that this day we think of an atom consisting of variety of smaller subatomic particles, but that wasn't so in 18, you understand? In the 18th century, around 18,000 around 80,000, that wasn't so, and that was because this experiment has not been performed by JJ Thompson, you understand? So many scientists actually believe that atom is the smallest particle of an element, you understand? But in 1897, JJ Thompson used cathode ray tube to discover electron, you understand? So we want to look at how electron was discovered by JJ Thompson using the cathode ray tube, you understand? Okay, so now this is how a typical cathode ray tube look like, okay? Here, please kindly pay attention. Here we have metal. We have metal plates. I will just draw some things I don't want you to understand. Let me paint this one. Okay. And let me paint this one as well with blue. Okay, now here we have the metal. You see, this cathode ray tube is just like a big tube of glass that looks like a bottle, you understand? It is sealed all over and it has two pieces of metal at this end, okay? You understand? So Thompson connected a piece of metal to a power source. Okay, see, look at this. A power source is just like a battery, you understand? So here, let me have a battery here, you understand? Let us have a battery. We have a battery here, okay? Let's call this a power source, okay? Power source. So now, after connecting the two pieces of metal to a power source, a ray shoots from this place of the metal. A ray shoots. See, do you know we have two plates of metal? This is 1 and 2. You understand? Now, after connecting a power source, you understand? Thompson discovered that a ray shoots from this piece of metal across the tube and created a glowing spot over here. See, from this point, after connecting this power source, Thompson discovered that a ray of light shoots from this point Then it created a glowing spot here. You understand? However, Thompson didn't really know what was going on. But what really happened was that electron was shoot from this piece of metal. You understand? It was shoot from this piece of metal and were attracted. You understand? It was attracted by this piece of metal which has an opposite charge. You understand? And they are moving so fast such that they will shoot all their way across the length of the tube. You understand? So anyway, Thompson sees the rays and he gets curious. You understand? He gets curious as to what is happening. Are you paying attention? So he begins to ask questions. These particles that the cathode ray is made of, does this have an electrical charge? Are you paying attention? See, the experiment was performed by JJ Thompson. You understand? This is the cathode ray tube. This, having connected the tube and the piece of metal to a power source, Thompson discovered that there is a ray across the length of the tube, but he didn't know what is happening. Now, what really happened was that when he connected this battery, electron was shoot from the first metal plate, and he gets attracted by the second metal plate. But because they are moving so fast, they find their way across the length of the tube. You understand? So Thompson gets curious and said, what is happening? What does these rays contain? Are they electrically charged? You understand? So in an attempt to answer the question, he takes two pieces of metal plates, you understand, and put them on the other side of the tube. Let me call this. Okay, please kindly pay attention. I want to redraw this so that the length of this place will be as long. You understand? You just have to pay attention, okay? I just want to redraw it. Okay? So it hit a spot here now. So now, in an attempt to answer the question as to whether these rays are electrically charged or not, Thompson takes two plates and puts it on the either side of the cathode ray. You understand? So this is the cathode ray. You understand? Cathode ray. Now it then turns off the electricity. You understand? The positive plate. This is the positive plate. And this is the negative plate, you understand? So having turned on the electricity in an attempt to check maybe this rays is electrically charged, he puts two plates, which the positive one on the top and the negative one beneath. When he turns on the power source, he discovered that instead of the cathode ray to travel on a straight line, the cathode ray bends towards the positively charged plate, you understand? Instead of the cathode ray to travel on a straight line, the cathode ray bends towards the positively charged plate. So that gave him an idea that if this ray bends towards the positively charged plate, that means that the cathode ray consists of particles that are negatively charged. You understand? You know that opposite charge attract each other. Are you paying attention? But unlike charge, they repel each other. So if this ray bends towards the positively charged plate, that means that this ray consists of particles that are negatively charged. You understand? So, but he was careful, you understand, as to be sure. So he proceeded to use a magnet. Are you paying attention? He didn't stop at this. You understand? This is just a step to know as to maybe they are electrically charged. This rays is electrically charged, you understand? But now, in an attempt to understand maybe the rays is negatively charged or positively charged, he took two pieces of metal and put it there. So he discovered that when the power was turned on, okay, let me put the power source, sorry. Let's put the power source. Okay. So he discovered that when the power was turned on, the rays bends towards the positively charged plate, indicating that the particles that the rays contains are negatively charged. But he wants to be sure, so he proceeds to use a magnet. Are you paying attention? Please pay attention. You know, if a particle has an electrical charge and it's moving, a magnet will push it in a particular direction. So it takes the cathode ray tube, you understand? It takes the cathode ray tube and then it surrounds it with a magnet, you understand? It wraps it with a magnet, and then do you know what happened? He observed that the cathode ray bends in the other direction. You know, when he makes use of two positive charge plates, two plates, one is positive and the other is negative, you understand? The cathode ray bends towards the positively charged plate, you understand, when the power is connected. Now he used magnet here, then the cathode ray bends at the opposite direction, you understand? This, please kindly pay attention. At this point, he discovered that surely if the cathode ray has a particle that is indeed negatively charged, this is how it is expected to move in the presence of magnets, you understand? So this is just another confirmation of what of the experiment that he performed. Hence, he discovered that the particles that the cathode ray contains are negatively charged. Do you understand? So from this cathode ray tube experiment, he is able to draw the conclusion that the cathode ray must be made up of particles that are negatively charged. You understand? You can see the particles are negatively charged. We tested with number 1 2 metal plates. They are electrically charged, and the charge that the particle has is negative. You understand? So we tested with number 1 2 metal plates. The second is the magnet. You understand? Which is for further confirmation of what he did. Now, point 2 is that particles that make up of a cathode ray are 1,000 times smaller than hydrogen atom. You understand? Okay. Then Thompson swaps out the two metals, you understand, in the cathode ray tube. He makes use of different types of metals to test maybe the result, the conclusion drawn from his experiment is candid. You understand? So he swapped these two metals. Are you paying attention? He swapped the two metals and uses different types of metal, but he finds out that all of the different metals that he uses gives up the same cathode ray, and regardless of the metal that he uses, the size of the particles in the cathode ray is the same. You understand? So he concluded that all different metals gives cathode ray. You understand? All different metals give cathode ray. So he swapped these metals, he changes them and use different metals. Are you paying attention? So he discovered that regardless of the metal that he uses, the size of the rays is the same. Are you paying attention? And all of them produce ray. So that leads to the third conclusion that all different metals gives cathode ray. You understand? So based on this conclusion, it comes up with the idea that atoms have tiny negatively charged particles inside them called electron. You understand? Hello? Atom has tiny negatively charged particles called electrons. So he called their names. The name of what he discovered, he called them electrons. So that is cathode ray tube experiment of JJ Thompson. This experiment was carried out in 1897. Trust you understand the class. If you didn't understand and if you have any question with respect to this, let me know in the comment section, okay? So that will be all for this class. In our next class, we're going to talk about more on atomic structure, okay? See you in the next class.